Last video we learned about geometric sequences, and now we're going to learn about geometric series. Now I think you can already guess by the name. This is the same thing as the relationship between arithmetic series and arithmetic sequences. So here I have a geometric sequence. And a geometric series is basically adding them together. And we have a formula here for finding the sum of a geometric series. Now let's try to prove this formula. So in our last video, we learned that we can represent a geometric sequence like this, where each term is equal to the first term multiplied by the common ratio to the power of the term minus 1. So as you can see here, represented by a times r to the n minus 1th power. Now if we were to multiply this entire thing by the common ratio r, we would get this. So now every term is a times r to the nth power, and on the left side we have r times Sn. Now if we were to subtract this from the original one without the r, we get this. This is very complicated, but just stick with me here. I promise it'll get easier in the next step. So now if we minus this thing, that's a negative AR right there. That's a positive AR, and those will cancel out. That's a negative AR squared right here. Remember, we're subtracting it right here, so that's actually negative. And that's a positive AR squared right there, so we'll cancel those out. And so on. This a to the r time to the n minus 1th power will cancel out with the previous term before this. So what we're left with is this. Now we can see a more smooth transition from the previous step, where this gets carried down to just Sn minus r times Sn. And here we have a positive a getting carried down, and a negative ar to the nth power getting carried down. So we get this. Now, we can factor out the a on the right side and the Sn on the left side, and we get this. But we want Sn to be isolated, so we'll do just that by dividing both sides by 1 minus r. And now we get the formula, and we've got it proven. So this is how to find the sum for a geometric series.